Hi, today I'm going to be teaching you with my 5-image story. This is Meteorology Homework 1, Part 4 by Sarah Clifford. All right, the general circulation of the air is shown in this diagram of the air in our atmosphere. There are many factors to the diverging and converging air, one of which is the movement of air from high pressure to low pressure. This is represented by the amount of air mass, and the molecules being shown are closer together here in the higher pressure and more spread out over here in the lower pressure system. Generally, the air will circulate from high pressure to low pressure, creating the direction of the wind in different types of weather. Another way to visualize this is having a balloon full of air, which is at high pressure, where all those molecules are really bundled up. And when you let go of the bottom, the air moves out, trying to stop itself from being trapped, creating wind and moving towards a lower pressure where the molecules aren't trapped and they can move a little bit more freely. Next up is the direction of the wind. It's going to always be determined as air molecules move from high pressure to low pressure. Upper level wind will have no friction to counter its effect, as surface wind is created because of the effect of friction. These winds are created all for the same reason. Pressure differences that arise because of temperature differences and unequal heating of Earth's surface. So you see here that it's going to go from high pressure to low pressure, and if we had arrows that were also leaving the low pressure system, they would move out into the next type of weather we may have. Next, we have to talk about the Coriolis Effect, which also explains the direction of the wind. As wind travels from high pressure to low pressure, based on the unequal heating of Earth's surface, another factor we need to add in is the Coriolis Effect. It simply means that because the Earth's rotation, wind always travels with a curve to the right as it is leaving a high pressure areas in the northern hemisphere and to the left in the southern hemisphere. So if this was completely the northern hemisphere, it would start here in the high pressure system, it would move up and then kind of slightly turn right. It would turn to the right as we go all the way down. In the southern hemisphere, it would be just the opposite. You would notice this also, another visual is to think like a rocket ship going up, but because of the wind or because of the Earth's rotation, it would slightly curve to the right every time, even though you wouldn't really notice that in the sky. Air moves based on high and low pressure systems. Inflow of air is called convergence, and the outflow of air is called divergence. Rising air is expanding and moves up as air cools and descends. So you could also see this as if it's going up over a mountain, and then as it cools, it's descending over the mountain. I like this visual because you can kind of see where it's more dense as well as where it's less dense and rising. Air moves clockwise in the northern hemisphere as a result of the Earth's rotation and having high pressure systems in the center. An impact on climate. The Coriolis effect in the wind direction is shown on this picture, and you can see that the different latitudes have different effects on air pressure systems. This gives the different areas seasonal temperature differences. The subtropical highs are responsible for trade winds. So that's going to be in this red, all the trade winds. As you see here, large land masses become cold in winter and have a seasonal high pressure system, which surface flows directly off the land. Overall, general circulations produced by semi-permanent cells of high and low pressures over water and is complicated by the pressure changes over land. So deserts and wetlands are wet or dry because of the way the air is cycled. And at the 30 to 50 degrees or 30 to 60 degrees here, in north or south of the equator, the air descends, making the air drier. So in the blue, where the westerlies are, it would be a drier climate. And the trade winds are created, so the red trade winds are created by the deflection of the Coriolis effect. So that these different winds kind of show what temperatures and climates would be like in these equal parts. And that is the end of my 5-image story.